So today we will discuss about fixed point number representation. Fixed point number. Before discussing about fixed point, let's understand how the information or data is being stored in a digital computer. So digital computer uses binary numbering system to represent all types of information inside the computers. So it follows binary numbering system, that is 0 and 1. And when I say all types of information, it can be numeric data or non-numeric or alphanumeric data. So numeric data means it contains only numbers or digits, and you know that numbers or digits can be classified into two, that is integers and real number. Integer means which don't have any decimal part or fractional part. In case of real numbers or floating point numbers, they have integer part and fractional part. And it is very cool. This is called numeric data. When it comes to alphanumeric data, it is a combination of both numbers and alphabets. So it is also represented using binary numbering system, but uses different techniques. First, we will see how to represent non-numeric, how to represent numeric data in digital computer. That can be represented by using two famous notations, two popular notations. One is fixed point number representation, and second one is floating point number representation. Fixed point, as the name specifies, fixed point, then something is fixed here. What is that point? Point means decimal point or binary point. So for a number, the binary point, if it is a binary numbering system, we call it as binary point. If it is a decimal numbering system, we call it as decimal point. So the binary point is fixed. The position of the binary point is fixed. Fixed in the sense, let's take a number 1011. So if it is a fixed point representation, the binary point, there can be two possibilities for a binary point. It can be at extreme left or at extreme right. So it is fixed at any of these position, either at extreme left or extreme right. If it is at extreme left, it can be a fractional part. If it is at extreme right, then it is called integer number. So this is an example of a fixed point representation. Remember, fixed point in the sense, what is fixed here? The binary point is fixed. Binary point is fixed. So the important thing is how to store a real number. A real number in the sense, as I said, real number means a number which contains integer part followed by binary point and fractional part. So this is called a real number. It is very important to understand this. The real number will have integer part and fractional part separated by a binary point. This is called a real number. So it is very important to represent, to know the representation of a real number rather than integer. Because see, the complex arithmetic means when you deal with real numbers or floating point numbers, you may have to do complex arithmetic because it contains both integer and fractional part. Let's take simple example. 123.5678 multiplied by 110.1234. See, this is called complex arithmetic. Why? Because it has, the first number is in a real number. Second one is also a real number which contains integer part and fractional part, integer part and fractional numbers. So doing multiplication is a very complex task here when you compare to simple integer multiplication. So the real dealing with real number is a very important and complex task which makes you to understand lot of things. Instead of that, if I have 123 integer 110, this computation is quite easy when you compare with the real number multiplication. So it is very important to understand how real numbers are represented in a computer and how you do computation with them. Let's take see, we have real number. In real number, these are the structures. Our first one is unsigned integer. Unsigned integer means just integer. Example of this is 123. We don't have any sign, unsigned integer. If it is a signed integer, same 123, but it can have sign plus or minus because it has sign symbol. So it is called unsigned integer, and another one is signed integer. So remember, in a C language or any programming language, if you say int a is equals to 0, by default it is a signed integer. If you want specifically represent an unsigned integer, you have to mention unsigned. You have to add unsigned word. Then which is better, unsigned or signed? That depends upon your requirement. For example, if you know, if you take unsigned integer, if you want to represent some large range of numbers, then you go for unsigned. If you want a limited range of integers but with signed, sign is also important, then you go for signed integer. And remember, in C programming language or in any programming language, when you declare a variable int a, the default one is signed integer, because by default it takes sign. If you specifically want an unsigned integer, then you can add the word unsigned here. So the example of this is 123. This is plus or minus 123. So you should know how to represent plus or minus. Plus is represented with 0, minus is represented with 1. Because ultimately in computers everything is required to represent in the form of binary. Even sign also has to be represented in 0 and 1 form. So the 1 is plus is represented as a 0, 1 is represented as 1, minus is represented as 1. Next, I have unsigned fixed point. In case of unsigned fixed point, I have integer part and fractional part. And signed fixed point means you will have a sign, integer part and fractional part. This is used for storing a real numbers. Floating point, in a sense, floating point means it is also, see, unsigned fixed point, signed fixed point is used to store real number, and floating point technique is also used to store real number. So floating point means it is very important to understand what is floating point. Floating point means it will have a sign, exponent, sign, and mantissa. We will see what is this exponent, what is this mantissa in detail. Just understand that if you want to represent a real number, there are two techniques. One is fixed point, other is floating point. Next, variable length, unsigned rational. Like that we have so many things. And the next point is, there are two major approaches to store the real numbers, that is numbers with a fractional component in modern computer. One is fixed point notation, another is floating point notation. What is fixed point notation? There are two major approaches to store a real number, that is number with a fractional component in computers. One is fixed point notation, another one is floating point notation. In fixed point notation, there are fixed number of digits after the decimal point. There are fixed number of digits after the decimal point, whereas the floating point number allows varying number of digits after the decimal point or binary point. To be say simple, if I have 123.567 and after decimal point it should have only 3 digits, it should contain only 3 digits. This is called fixed point representation. Floating point, yes, after decimal point you can have n number of digits after the decimal point. It is called floating point. It is called fixed point. So what is fixed here? The number of digits after the decimal point is fixed. The number of digits after the decimal point is fixed here. Next I have, see, first we'll discuss about fixed point representation. In fixed point representation, the representation has fixed number of bits. This representation has fixed number of bits for integer part and for fractional part. So even for integer part it is fixed, the number of digits are fixed. Even for fractional part, number of digits are fixed. For example, if given fixed point representation I, then you can store minimum value. Integer part can be zeros and fractional part is 1, because it should not be 0, right? So if I have a I, 4 integer parts followed by 1, 2, 3, 4 for fractional part. This is the so each fixed point representation will have a specific format. So what is the minimum number? 0, 0, 0 dot 0, 0, 0, 1, and the maximum value is decimal number 999 dot 999. There are three parts of a fixed point number representation. One is sign field, integer field, and fractional field. See, again fixed point number representation has it can be signed or unsigned. If it is a unsigned one, this is the representation where we have integer part and fractional part. This we know. And the important thing is signed fixed point number. In case of signed fixed point number, we have a sign bit, integer part and fractional part. This is important thing. Next, we can represent these numbers, fixed point numbers, using, this is important. Okay, we are saying that a real number can be represented using fixed point and floating point. But how to represent or how to store this fixed point representation, in memory? Ultimately, this number has to be go and store in the memory. So how to store this number in the memory? There are three different techniques, and most popular, very popular. One is signed representation, another is ones complement, second one is twos complement. So these are the very popular representation of a number. Maybe it is a fixed point number or a floating point number. So this has to be represented or stored in a memory. See, signed representation means minus 2 power k minus 1 minus 1 to 2 power k minus 1 minus 1 for k bits. Let's take a simple example. Let's assume, before understanding this formula, let's apply k value to a simple value. Let's assume k is equals to 3. K is equals to 3 means, what do you understand? There are 3 bits in the memory, and in the 3 bits you can store the minimum value 0 and maximum value is 1. This is 0, this is 7. This is unsigned representation. But what we are talking here, signed representation. So in case of signed representation, out of these 3 bits, 1 bit has to be reserved for signed bit, and the remaining are magnitude or integer part, right? So what happens, let's take for same 3 bits 0 0 0 0 0 1 0 1 0 0 1 1. As I said, in this representation, this is called sign bit. Moreover, it is 0 means plus. So 0 means this number is plus, this is number plus, plus, plus. What is this? 0. What is this? 1. What is this? 2. What is this? 3. Right? Similarly, if you keep 1 here, you will get another 4 numbers. 100 means minus 0, 101 minus 1, minus 2, minus 3. So you are representing minus 3 to plus 3. But the interesting thing is, here in signed bit representation we have even sign for 0, which is not acceptable. As per mathematical formulas, 0 doesn't have any sign, right? But what's happening in signed representation, we are getting two representation for 0, that is plus 0, minus 0. So we are getting plus 3 to minus 3. Now we have take the formula. We are going by reverse engineering process. So for k minus 3 to plus 3 minus 2 power k minus 1. K means 3. 3 minus 1, 2 minus 1 means 3 minus 1, 2. 2 power 2, 4. 4 minus 1, 3. Minus 3. Similarly, 2 power k minus 1 minus 1. That is plus 3. So minus 3 to plus 3. This is the range. This is called range of the signed representation in memory. See, now we are talking everything how the number is stored in the memory. It is most important thing. Next is ones complement representation. For same 3 bits, minus 2 power k minus 1, again minus 1, 2 power k minus 1 minus 1. So this is the range of the numbers. This is the range, means this is the minimum value, this is the maximum value that you can represent in a 3 bits in a computer memory using ones complement. But before that, we should understand what is meant by ones complement. We will discuss in detail, but just for understanding purpose, ones complement means, let's take 100. Complement means make 1 as a 0, 0 as a 1. This is called ones complement representation. So important in representing the fixed point number or floating point number in computer memory. We will discuss, just remember. Next, two's complement representation, which is a popular representation, and most of the computer uses this two's complement representation. We will discuss in detail about that. But what is a fixed point representation means? Let's take a number. First, you apply ones complement, convert 1 to 0, 0 to 1, and add 1. 1 plus 1, 1 0, 1 plus 1, 1 0. This is called two's complement. Two's complement means first apply first complement, then add 1. You should get a doubt why we are doing this to represent a number in a computer memory. See, before storing a number in a computer's memory, you have to do all these things. It is very time consuming, right? See, the goal is either you should, I'll tell you, in sign representation you are getting plus 0, minus 0. In ones complement also you are getting plus 0 and minus 0. To overcome this problem, we have two's complement representation. And you can verify by yourself that two's complement will have only 1 0. One representation for 0. 1 0 means one representation for 0. That means only one way. In two's complement, suppose only one way to store the 0 in computer's memory. It is important one. And two's complement representation is preferred in computer system because unambiguous property and easier for arithmetic operations. Unambiguous property in the sense, as I said, it doesn't contain plus 0 and minus 0. But whereas sign representation, ones complement, they have two representations for 0, which may create some ambiguity while doing any computations. And let's take an example, simple example. Assume that number is using a 32-bit format. 32-bit formats. Like I said, k is equals to 3. Now we have k is equals to 32-bit. Now you should understand. If someone says 32-bit operating system or 64-bit operating system, means they can perform computations on 32-bit or 64-bit parallelly. It is called 32-bit and 64-bit OS. So assume the number is using 32-bit format, which reserves 1 bit for sign and the remaining 15 bits for integer part and 16 bits for fractional part. So now we are trying to represent a fractional number which has two parts. One is sign part, one is integer part, and another one is this is integer part and this is fractional part. Here 1 bit, 15 bits are used for integer part, 16 bits are used for fractional part. It is very important to know about this integer part and fractional part. Now Let's take a simple example. Here we have one number. What is the number? Minus 43.625. You have to represent in fixed point representation. If somebody asks you what is fixed point representation, there are fixed number of digits in integer part, sign bit, and after decimal point, fixed number of digits for fractional part. What is fixed here? If somebody asks you represent a number in fixed point, what you have to ask them? How many bits I should preserve for integer? How many bits I should preserve for fractional part? So 16 bit for fractional, 15 bits for integer, 1 bit for sign. So in a total 32 bit. Now we see how to represent this example minus 43.625. First it is a negative number, so the sign bit should be 0. Remember, negative is represented with 1, positive is represented with 0. Next, integer part. Take 43, convert into 43, convert into binary number. How will you convert 43 into binary number? I will tell you the shortcut 2 power 0, 2 power 1. It is used for competitive exams as well. 2 power 4, 2 power 5. 2 power 5 is 32. So it should be 1. So 43 minus 32, 11. So 11 means under 8 you can place 1. Here. So this is the representation. 101 011. This is the representation. But I said you reserved 15 bits for this integer part. So you just add 1, 2, 3, 4, 5, 6. For 6 bits we have, you just add 9 bits 0. That becomes integer part. That becomes integer part. See here. Next we have fractional part. How do you represent fractional part? Representing a fractional part, 625 is the fractional part. So first you should know how to convert this fractional part. 0.625 into 2. How much it would be? 1.25 are 10, 2 2 are 4, 5, 2 6 are 12, 13. 2 5 are 10, 2 2 are 4, 5, 2 6 are 12. 1.250. Takes the fractional part 250, multiply with 2, 0.500. Take 0.500, multiply with 2, you will get 1. So stop this process once you get 0, 1, because after, what is the fractional part for 1? 0, 0. Even if you continue 0, 0.0 multiplied by 2, you will get 0, right? So what is the number here? What is the number means? 101 is the number. So this is the way of converting a fractional part into number into integer number. It is very important to know. So the 0.625 is the fractional part. It's a decimal number. Its equivalent binary number is equals to 1.101. Because we have 16 digits for 16 digits for fractional part, you can add 13 digits. So remember, we are adding here. If you add here, the value will get changed. Left hand side, if you append fractional part. But if you append at right hand side, nothing will change. So next we'll see So this is about sign representation, one's complement, two's complement, how a fixed number is represented. Just remember one thing, fixed number means the number of bits for storing integer part is fixed, the number of integer for storing the fractional point is also fixed. So in case of 32 bits, I have 15 bits reserved for integer part, 1 bit for sign, and the remaining 16 bits for fractional part. So this is about this is called fixed point representation. Next we see when 0 is represented plus and 1 is represented, this is the 15-bit binary value and decimal 43 16 binary value. Okay. The advantage of using fixed point representation is the performance and disadvantage is relatively limited range of values that they can represent. So the advantage of using fixed point representation is performance and the performance. Performance is fast, and the disadvantage is relatively limited range of values that can represent. See, when you go for floating point, there is no limit for fractional part. There is no limit for integer part. But for fixed point representation, we have a fixed number of bits allocated for integer part, fixed number of integers allocated for fractional part. This is the disadvantage. So that you can represent only relatively limited range of values. But the advantage is that it has performance is faster. So the smallest number that you can represent using fixed point representation is make sign bit 0, okay, and integer part 0, fractional part 1. The largest is 0, integer part all ones, fractional part all ones. I think you can represent sign bit 1 also here because it is a minimum value. And when it comes to, so we'll see next, these are the smallest positive number. Okay, he's saying smallest positive number and largest positive number which can store in a 32-bit representation as given in the above format we discussed just now. We have seen, therefore the smallest positive number is 2 power minus 16 approximate, and the largest positive number is like 32,768, and the gap between these numbers is 2 power minus 16. You can move radix point either left or right with the help of only integer field is 1. So fixed point representation. Fixed point representation doesn't reserve the specific number of bits for integer part and fractional part. Instead, it reserves certain number of bits for the number called mantissa or significant, and certain number of bits to say where within the number the decimal place sits called exponent. This is very important. What he is trying to say, so far we understood that this fixed point representation doesn't reserve, it reserves the specific number of bits for integer part and fractional part. That was our understanding. But what is saying, sometimes this representation doesn't reserve specific number of bits. Instead, it reserves a certain number of bits for the number. Called mantissa. That number is called certain number of bits for the number. It is called mantissa. Here comes a new word, mantissa. Certain number of bits for the number called mantissa or significant, and certain number of bits to say where within the number the decimal place sits called exponent. So these are the two different terms that everyone must understand. Mantissa means certain number of bits for the number, called mantissa are significant, and a certain number of bits to say where within the number the decimal place sits, called exponent. So the total number will have mantissa. In the mantissa we have exponent. We'll discuss in detail about mantissa and exponent. Just remember this point. Floating point representation has a special term called mantissa and exponent. Next comes floating point number representation. Floating point representation number has two parts. The first part represents a signed fixed point number. A signed fixed point number called mantissa. So floating point number has two parts. One part is signed fixed point. Signed fixed point. This is called mantissa. The second part of designates the position of the decimal point and it is called exponent. So second part says where the decimal point, because in floating point number there is no fixed representation for a decimal point. So in case of fixed point you can say that 15 bits are stored for integer part, 1 bit for sign bit. After the decimal point starts, then comes fractional part 16 bits. But in floating point, this position of the decimal point or binary point is nowhere fixed. You have to you have to confirm where that decimal point exists. So it can exist after 2 bits, after 3 bits, after 4 bits, or at any position. So the binary point or decimal point position is not fixed. So you should mention where it is. This is called exponent. Okay. So I'll read once again. Floating point number representation of a number has two parts. The first part represents a signed fixed point number called mantissa. Second part of designates the position of the decimal point or binary point called exponent. The fixed point mantissa may be fraction or an integer. The fixed point mantissa can be it's a complete fraction or it's a complete integer. Floating point is always interpreted to represent a number in the following form. MXRE is a very famous notation. MXRE. Mantissa, radix, exponent. Only the mantissa M, exponent E are physically represented in the register. So out of these two, only mantissa and exponent, only these two are represented in 32-bit or 64-bit register, including their sign. A floating point binary number is represented in a similar manner, except that it uses base 2 for exponent. A floating point number is said to be normalized if the most significant digit of the mantissa is 1. It is very important. See, if somebody asks what is a floating point representation, you just represent this number MXR, mantissa, exponent. What exponent says? It says the position of a binary point. Mantissa is a fixed point number. Fixed point number means it can be complete fractional part or integer part. Okay. So what it says means I will give you a small example. Only the mantissa and exponent E are physically represented. You will see an example. Let's take this example. This has sign bit, exponent and mantissa. If the most significant bit means this one. This is LSB. Remember, we discussed in the previous card, MSB and LSB. If MSB is always 1, this is called normalized form. Just remember this point, why it is so important. We'll discuss later. Normalized form of a mantissa. So the actual number is sign bit -1. Yes. Next, mantissa 1 plus m. What is, why we are doing 1 plus? I'll say that into 2 power e minus bias, where s is the sign bit, m is the mantissa, e is the exponent, and bias is the bias number. This is the formula for representing a floating point number. We understand step by step process. Just remember, this is the representation.